This video highlights 10 things I learned while building 5 raised bed gardens. Check out the links below to my other videos showing the raised bed build from start to finish. Footer sizes depend on the block size and type, the bearing capacity of the soil, and the potential weight of everything set on the footer. The rule of thumb is twice as deep as the thickness of the wall and twice as wide. So if I were to place a structure on top of my concrete block walls, which are 6 by 8 by 16 hollow concrete blocks, I would need a footer 12 inches thick, 12 inches wide. However, because the only weight the footer has to carry is the weight of the blocks, and there's virgin soil beneath the footers, although very wet at the time, I reduced the size to 4 inches thick and 10 inches wide using pressure-treated 2x4 lumber for framing. Before building the footer frames, I scraped the soil as close to level as possible. Then I strung mason string from the front left corner to the back left corner and placed wooden stakes every 6 feet. Using my transit, I drew a line on the stakes to indicate where to place the frame and then used 1 5/8 deck screws to secure the frame to the stakes. I repeated that process for the right side of the frame. With the outside of the frame leveled and secure, I added the inside frame using wooden stakes and cross braces to secure it. If you do not have a transit, other methods include water or string levels. It is best to dry fit blocks before pouring concrete. To check my measurements, I placed 5 blocks in the positions they'd occupy on the footer, leaving 3/8 inch gaps to simulate the mortar joints. I made the footer 2 inches wider than the wall for structural purposes and for placing pavers at a later date. Note how the blocks are staggered for each row in this partially completed end wall. The next step is placing and compacting gravel. I put 5/8 minus gravel inside the frame and used a T-shaped plywood template to spread the gravel throughout the frame. When done, the gravel was level with the bottom of the 2x4 framing. Then I used a steel tamper to compact the gravel. Tamping the gravel compacted it so it was about a 1/2 inch below the frame. It was not enough for concrete to leak out, but it was enough to give me a full 4-inch thick footer. Washington State experiences over 1,000 earthquakes every year. Most are too small to notice, but they are strong enough to shift the ground all over the state. Due to this constant seismic activity, I needed to ensure the block walls would not shift on the footer. So I placed 10-inch pieces of 1/2 inch rebar for the corners and every 32 inches along the wall. Once I complete the walls, I will place a longer piece of rebar in the holes. The rebar touches the footer next to the existing piece, providing an 8-inch overlap. I'll fill the hole with concrete to prevent the walls from shifting on the footer and to reinforce them to withstand outward pressure from the garden dirt. When poured, the footer looks like this with the rebar in place. Mason string is the best way to ensure straight and level lines. I positioned string for the front wall and the side walls. I placed chalk lines on the footers to mark the inside and outside edges of the blocks to assist me in setting the mortar bed. At the other end, I placed 1 block on a 3/8 inch piece of plywood. The plywood simulates the thickness of the mortar bed. I also ensured the block remains the required 2 inches from the outer edge of the footer. The accuracy of the first row is critical to ensure all subsequent rows come out straight and level. As shown here, after placing the first row correctly, I now have square corners and straight and level walls. Because I am not a mason, I needed a way to overcome my inexperience with mortar placement and thickness. My solution was 2 3/8 inch bars bent into a U shape. When placed on the top block, the bar allows me to add mortar, place the block, and tap it down to the bar, and when finished, I can pull the bar out, leaving just a small hole. I leave the first bar under the previous block, and when placing the second bar, I ensure it does not interfere with mortar placement by positioning it around the web. Next, I butter the end of the block, and again, I'm not a mason, but I found that by placing 1 trowel full of mortar and then spreading it from the center to the edges, I end up with a nearly perfect 3/8 inch joint. After placing the block, tapping it into place is simple, requiring just a few taps in the end and the top. I use a torpedo level to ensure the block is level and aligns with the lower rows. I remove the spacer and move to the next block. That U-shaped spacer allows me to move quickly, knowing that my mortar joints are exactly 3/8 of an inch. I need to offset each row by half a block length from the previous one. The block ends must fall on the webs, not between them. To demonstrate this, I've dry placed a block on the third row which fits as expected, but the top block, which placed over the webs, leaves me with a gap because the blocks I'm using are only 5.5 inches wide. The simple fix is a spacer cut from one end of a block. It is critical to reinforce the walls to resist outward pressure. Cut rebar pieces 1 inch shorter than the wall height. Cut one for a template and mark the rest using the cut-off saw. To make it easier to cut each piece, I used the hole in the top block to hold the saw while I rotated the rebar against the blade. Everywhere I placed 10-inch pieces of rebar in the footer, I filled the cavity with concrete and inserted rebar for vertical reinforcement. I stuffed 2 concrete bags into the holes without rebar and pushed the bags down enough to allow me to fill only the cavities in the top block. Filling the holes prevents bees from building nests in the wall cavities. I planned to place pavers between the beds and around the perimeter, so I made sure to always sweep the excess mortar off the footers.